हाँ सर, प्लीज।
We are going to discuss design and implementation of these DC-DC converters. Now, today's objectives will be will teach you how
Students,
to
online
design
workshop
these
is going on.
DC-DC converter, one of the converter. After that, component design and component selection methodology. Then I'll also show you some design converters, and then hardware implementation and their obtained results will show you. So this is one of the application wherein you need multiple converters to be connected together. This is a low voltage DC microgrid. So wherein you can see here there is a battery bank, and then there is inverter, half bridge inverter. Then there is high frequency multi winding transformer. So this has got one primary and multiple secondaries. So you can see here there are three secondaries, and then this will be generating 5 volt DC for some loads, 20 volt DC for some other loads, and again 50 volt DC for few other loads, like that. So depending upon power level of the loads, okay, this will be done. So here also you can see one the boost converter here. So uh, this is design of this is a DC to DC converter, boost converter, and this will be explained by Professor Kasar now, and he will explain you working of this in brief, and then depending upon these parameters, design value of design value of C, these further he will also teach you how to design. Now this is I'm handing.
Good those who are attending the online workshop. Am I clearly audible to all of you?
Yes, sir. Yes, sir.
Yes. I have shared the screen of presentation.
Yes, sir. Sir,
Okay.
kindly put in slideshow mode if possible, sir.
Yes, sir. Yes, sir. Oh, okay. I hope the slideshow view.
Yes, sir. Now it is clear.
Okay. First of all, as Dr. Brief introduction that what we are going to learn to design and create in this workshop. uh, I will just briefly take the that sir has discussed few minutes back. This is a very classic example of LVDC, low voltage DC. If you see at each level voltage from, if you see the each stage of this block diagram, starting from the source, what is the source voltage here? Yes, students, you can
Battery
unmute
bank, sir,
and give
for
feedback.
48 volts battery bank.
Yes. So here input or the source voltage we have taken is 48 volt, which is in DC. But in low voltage DC microgrids, or maybe you have heard about distributed generation power plants, we require multiple DC voltage levels. And for that multiple DC voltage levels are depend on the requirement of consumers or the requirement of load. As the DC supply system is not regulated yet, the regulation of voltage is not done in case of DC. अगर हम AC की बात करें, in day to day life we use AC supply. What is the supply voltage at our home? हमें सब पता है, घर में AC वोल्टेज की वैल्यू कितनी होती है? Yes.
Sir, 230 volts, plus minus 10
Yes,
volts.
exactly. At the home for domestic application, we are using 230 volt single phase 50 hertz AC voltage. The term I have used, that is regulation of voltage. This regulation of voltage is already done by utilities in AC. All the loads, all the devices, electrical devices that we are using at our home, starting from ceiling fan or the light sources, all they are designed to work at 230 volt AC supply. This is nothing but the regulation of voltage at consumer level from the utility. But this regulation in DC supply system, still, if you see multiple DC applications, for your mobile charging you require separate DC voltage. For laptop charging you require separate DC voltage level. For your, you can say, the EV charging, you require separate DC. If you have the electric car, for its charging you require separate DC. This is I'm discussing of regulation of voltage. This regulation or the standardization of voltage is clear in your minds. Our digital data. These DC to converters are required because in multiple DC applications we require very high voltage levels. And various types of voltage levels, just like we are seeing in laptops, 20 volt, 30 volt. Each voltage level is different. These voltage levels are required for different types of applications. The design of DC converters. Here I have clear the point. What we are going to learn, that we will see in the upcoming discussion in the next 1 hour. But why we are learning this, I hope this point is clear while you are attending this workshop. Why we need to DC converters? Because voltage levels for multiple DC applications. That voltage conversion plays a very role in the of all DC applications. Is the point clear with all of you?
Yes, sir.
Okay, so with context to by or with respect to this introductory context that I have just explained, the DC to DC also link the chat box. Google, open the chat box. There is www. This link is received. Click on the link, then one open-ended question will appear in front of you. After clicking on the link, know about DC to DC converters. All participants are requested to share your opinions or your answers or responses for this question by using that link. Any queries while accessing the link? Am I audible? So quickly share your responses or the answers. We are not going to discuss regular technical definitions. Whatever you have already know or any information about DC-DC converters, please share your response because this interaction must be there. Otherwise, it will be the just you. Yes, we have the two responses. Here, your name will not be appeared, so don't worry about the name and roll number. Feel free to give the answers. Yes, we have the one response. It's a circuit or device which can convert DC voltage one level to another. Yes, examples are buck converter and boost converter. Yes, DC-DC converter, it converts one DC voltage to another. Yes, we have many participants. Please share your responses so that step by step you will get the clear idea. Yes, what about others? We'll shift to the next point. Feel free to answer here. This is just a very introductory question. What do you know about DC to DC converters? Because in last 5 to 7 minutes we discuss why we require DC DC converters, and in our next discussion we will start with the working of boost converter and the design cycle. Before moving towards the its working, you must have the idea of DC DC converters. Yes. Okay. So I hope the need behind DC to DC converters is clear to you. Okay, we have the other point which we will discuss is an electronic circuit, right? That converts DC to AC. Yes, good. Now we will continue our discussion of DC DC boost converter. Now the Word document file, is it visible to all of you on your screen? Is the document visible to all of you on your screen?
Yeah, it's visible, sir.
Okay. So as we received multiple responses about DC to DC converter, the major two types, or actually there are three: buck converter, boost converter, and buck boost converter. But right now we are our shifting our focus to the discussion of DC to DC boost converter. First, we will try to understand the how this circuit works, and then we will shift to the design of DC to DC boost converter. Okay. So, what is the definition? The DC to DC boost converter is an electronic circuit which is used to increase the voltage of DC source. I can relate this with step up transformer in case of AC. What is the application of step up transformer? Or what is the main feature of step up transformer? Yes,
Uh, like it it steps up
input
the
voltage
DC voltage, like from the output is more than the input actually.
output is more than input.
Yeah.
Secondary voltage is much. Here, the same principle is there. Only our supplied voltage in DC to DC boost converter much better than the input voltage. So now we will discuss all the components of the circuit diagram. If you see the circuit diagram carefully, as we have seen in semester 4 itself, I hope everyone is clear about the circuit diagram and the working of the circuit. If जैसे ही आपको समझ में आएगा, then design part. So what are the components? This is voltage Vs, bias which is flowing towards inductor. Inductor is connected towards source side. Then this switch is nothing but power electronic switch is used for switching purpose. Then diode is connected, and at the load side we have shunt capacitor, that is C. It's connected in parallel fashion at the load side. I hope the circuit diagram is clear to all of you. Now, how this circuit works? So, as I just said, in various real life applications, battery powered devices, renewable energy systems, or LED drivers, we require boost converter. Now, what are the components of boost converter that I have discussed just now? There is initial DC voltage that you want to boost. Then there is a at the source side. Okay, so inductor will store the energy in the electric field and it will release whenever it's needed. So that is the second and most important, uh, I can say, the component that we will see its design later. Then power electronic switch, it can typically a power electronic, various switches are there like MOSFET, IGBT, SOI. They are controlled by the gate pulses. On off action, they control the flow of current, or they control for how much time that circuit will be in on state and for how much time circuit will be in off state, or it will control the conduction of boost converter. And lastly, we have the diode, capacitor, and load. As we all know, diode is a unidirectional current device. Current always flow only in one direction. So this diode allows current to flow in one direction and it prevent from flowing backward. We Everyone knows the application of diode. Then we have the capacitor, which is connected in shunt fashion, as we have seen in this circuit diagram, and we can connect a resistive load towards load side, and across the load we are obtaining the output voltage. So I hope the connection and the circuit diagram components it's clear with all the students, those who are present. Can I move forward?
Yes, sir.
Okay. Now, as circuit diagram is clear with everyone, we will now discuss the operation of boost converter. Can anyone tell me if do you know anything about working of boost converter? How this circuit works? Just a very simple question. I am not interested in detailed answer. Try to understand. जितना भी आपको पता है how this circuit works, you can tell either in Hindi, Marathi, or English, any language that you are comfortable. But please respond for any live question. कैसे काम करता है boost converter? Yes.
Sir, it actually acts like works in two modes.
Yeah.
One where the switch is on and another which when the switch
First,
is off.
switch has two operating conditions, right? First, switch will be in on state. So we can say switch is in on and switch is in off. That is the accurate expression. When this switch S is on, can you elaborate that point?
Sir, couldn't hear your question. Can you please repeat it?
When switch is in on state, switch has two modes of operation for the boost converter. So when switch is in on state, how this circuit works? That is the
Switch is in on. Sir, when the switch is on, I think so. The inductor stores the energy.
yeah, yeah,
And then
right,
when the
very good.
switch goes off, the diode acts in
Yes,
forward mode, and then the this load gets the output. I think so.
yes,
Two modes.
right. I hope you are all thing clear with me. Now I will explain working of boost converter. How circuit works? Around the switch, the inductor is connected here. This power electronic switch, it has two conditions. Either switch is in on state and switch is in off state. So if you see, first initial state, that switch is open. So in the beginning, when the switch is open, no current will flow through the inductor. Okay, current will flow across the inductor and load, but at this point of time, any current will not flow through the inductor because diode is already off. When switch is on, it boosts the inductor. switch switch on है मतलब वो close है. It will allow current from the source to the input side, but so allow the current from the input side to the inductor. Okay, the inductor is open. So what we are now discussing is the power electronic switch is in on state or off state. Any different power electronic switch, you can put that answer in the comment section. So those who are present, already I have given the examples and just different names of power electronic switches that you already know, but that will make your understanding more better. So by clicking on the link which is there in the chat, I have given many names of electronic switches. Any response? GTO is right. widely used switch is also there. Yeah, and right, it is any other SR right. IGBT is there. Then we have the yes, thyristor is also there, right? So these are the different power. Thank you for your responses. So these are the various types of power electronic switches that we used here. Whenever I say switch, जो भी आपने अभी example दिए, I'm talking about those power electronic switches. Okay, so we have reached at second part of the working, that is when switch is in on state, it will start the boosting process. It will allow the current to flow from the input through the inductor. So now we have the clear idea what are different types of DC-DC converters. We are discussing about boost converter. We have understood the circuit diagram. Now we are discussing the working. But in the working, this inductor plays a very important role. So I just understand why used convert property of inductor can all of you why specific and है जिसके लिए it is a very वो it's about current that is flowing through the inductor. What is the property? I will that the answer that I was looking for towards source side factor regarding the flow of current is allows current which is flowing. I will repeat my never allows flowing through it. Happens when boosting process will go through the air, resist the change in energy regarding current. Clear to all of you? Towards source side, which is in on state, current will flow and and on state or through the property है वो उसके is through the diode. So the inductor it will voltage and here than the diode and fashion capacity
Alright,
उसमें कोई output voltage. Those situations are
no problem, muted. See, they are getting
your voltage.
नेट चल रहा है नीचे नेट चल रहा है क्या
Now how this process
क्या क्या
switching
कट रहा है बोलो
if
बोल
you
नहीं
have
सको बोलो
मतलब
excuse me sir
yes sir.
sir some students are telling that the voice is coming cut from your side hence objections are coming sorry to
Uh,
interrupt
Am I clearly audible, sir?
Now students tell, is it audible now?
बीच में कट हो रहा है क्या सर?
Sir, in between there is like minor disruption in the voice, sir.
Okay.
Like it
Is
cuts
is
in
it
between.
okay right now?
Yeah, right now it's okay, sir.
Okay, okay. Okay, I will take care about this. अगर कभी साउंड मेरा ब्रेक हो रहा है तो यू कैन इंटरप्ट मी एंड यू कैन टेल मी इमीडिएटली सो दैट that part I will repeat. Okay, thank you for this. I will take care about the voice. I hope the working part is clear with everyone. We started with the discussion of low voltage DC microgrid. We first discuss about why we require DC to DC converters because DC voltage ये extended value में single phase 50 we don't have the standard of DC जैसे कि आपका मोबाइल आपकी कार है हर एक डीसी एप्लीकेशन का वोल्टेज लेवल अलग है so we have to convert the DC voltage from one level to another. For that specific purpose, the role of DC to DC converters is very crucial in upcoming days in this era of electric cars and electric bikes and the renewable energy sources also. So we then started discussion about DC to DC boost converter. We discussed the circuit diagram, the two very important parameters from the design point of view, that is value of inductor and value of capacitor. Okay, so I just explained very thoroughly how this circuit works. We have few questions also, question answers also. So I hope all the fundamental part regarding working of circuit is clear with everyone. The design part, yes, of DC inductor about high capacitor side switches clear. Design design is uh,
Sir, your voice is breaking again, sir. Since you
yes.
started the design parameters.
Please repeat the question.
Sir, your voice breaks, sir. Your voice got cut, sir,
It's
when
still
you started
breaking.
designs.
Okay, let me.
मैडम नेट चल रहा है क्या बड़े आपका? नेट नहीं चला वो कहाँ कहाँ से बात लेकर ढूंढे था नहीं भाई मैं टीएनपी से जियो फाई मांग के लेके आया टीएनपी से वही यूज कर रहा हूँ मेरा लैपटॉप
Hello, am I audible?
Yes, sir. Right now, yes.
Any part of what due to or the working part? I will repeat that part quickly.
Uh, Sir, your voice breaked again, sir. Actually, right now when you asked.
Let me just 2 minutes. I have the designer add size. Okay, so it should before. So the ripple voltage again the specific. So any query you can take any other calculation. Input voltage become 12 volt, and if you want output will
So,
come 24. Yes.
how can we know that value of Iomax? Is that a load input current, output current?
आपको बूस्ट कन्वर्टर का एप्लीकेशन कौन से चार्जिंग पर्पस के चार्जिंग बैटरी चार्जिंग करंट ऑफ बैटरी दैट विल बी योर फॉर एग्जांपल अगर आप मोबाइल चार्जर डिजाइन करंट अभी तो जो फास्ट चार्जर हम यूज कर रहे हैं 1 to 1.5 एम्पियर और 2 एम्पियर तक भी जाता है सो दैट 2 एम्पियर विल बी योर IO max. Here I have taken these values. Input voltage is 50 volt and output voltage is 200 volt and load current is 4 ampere. Now any query about these three parameters?
No, sir.
Yes. I think the student who has asked about current, the query, are you clear about this?
Yes, sir.
Okay, so what is the requirement of your it depends on your application. Okay, for what application you are designing this boost converter. So we'll start with the calculation part. Now this is just like the numerical that we will solve in our day-to-day lectures and practicals. First we will calculate the maximum value of out as we product of voltage and current. So I think VO is 200 and IO max is 4. So what is the maximum value of output power? It is 800 watt. Okay. So first calculation is very easy. Maximum value of output power, product of output voltage and output current. Okay. I hope it is the second step, that is resistance. Okay. Because in the circuit diagram, as we have connected load, जिसके पहले कैपेसिटर है, कैपेसिटर के बाद दिस इज अवर लोड टर्मिनल्स एंड वी आर टेकिंग एग्जांपल ऑफ रेजिस्टिव लोड एंड वी आर okay, our basic Ohm's law, how to calculate RL max. RL max is equal to output voltage and divided by I. VO divided by 100 divided by 4. Why we are calculating this point? जैसे कि हम सिमुलेशन करते हैं कोई भी सॉफ्टवेयर में, दैट सिमुलेशन विल एंड own boost converter, we should be ready with our own calculated parameters. Then only you can simulate and then only you can go for the component selection and this calculate. So until this point we have calculated two values: output power, that is 800 watt, maximum value of load current, that is 50 ohm. Now for the calculation of duty cycle, it is important to calculate the maximum value of DC transfer function. So before going forward, again, click on that link. And how much do you know about power electronics? Which is available in your chat box. And let me know, what do you know about the duty cycle? This question is open for all, because now we are going to calculate that. But before calculating, at least हमें पता होना चाहिए कि ड्यूटी साइकिल क्या होती है. Yeah, try to respond quickly. Yes. Duty cycle plays very important role deciding for how much time that circuit will be. What is duty cycle? Difficulty. Duty cycle is nothing but the fraction of discussing about the because those switching time of power electronic switch a definition response is of on total total addition is nothing but you take a show all time. Okay, for now maximum क्यों कर रहे हैं साइकिल के फॉर लगने वाली है ट्रांसफर फंक्शन इट इज वेरी इजी with the input what is maximum our हमारा and what is our in source side so what is the value of it is divided by 50 action efficiency percent of efficiency I applications is the participant n आपके केस में वीओ एंड वी की वैल्यू अलग हो सकती है आई एम हियर जस्ट टेकिंग द एग्जांपल इनपुट वोल्टेज 12 वोल्ट होगा अगर ना है तो आपका आउटपुट वोल्टेज 24 वोल्ट होगा दैट विल बी द ओनली चेंज एंड दिस करंट इट डिपेंड्स ऑन द लोड जितना कि लोड को चाहिए वो करंट की वैल्यू रहेगी दैट वी कैनॉट डिसाइड दैट लोड विल डिसाइड वॉट एवर द एप्लीकेशन for that we are designing the boost converter. Okay, so now we will calculate the duty cycle minus efficiency DC trans I will say 1 minus 9 it is 4 point and the value of maximum duty cycle 0 point की duty cycle get the percent 7 point ये आगे मतलब क्या है मैक्सिमम 70 बोल नहीं बूस्ट duty cycle
Hello, sir.
of total yes is the four first
Sorry, sir, your voice is breaking.
सार्थक आवाज नहीं दिया, सुनाई नहीं दिया, जोर से बोलो। जो
अगर
हेमंत
कोई
सर के
क्वेरी
सामने है उसके लैप में बोलो, डाउट पूछो।
was 40
दैट्स व्हाई आई टोल्ड यू लैपटॉप ऑन करने के लिए बोला मैंने आपको।
continue with mm, say that is हुए हैं, मैं आपको बता in this output voltage here, that is 50 volt, my output ampere assumption 90% convert, then it is for time period, so that percent is calculation capacitor value of L in Henry in. I hope all these or what is the formula required? Max is equal, it's in the numerator we have the product multiplied by the maximum d max denominator face stand, we have finalized frequency that while selecting the known parameters we have finalized the switching frequency to 100 kilohertz, right? So I will substitute all the values in this formula. RL max, that is maximum value of load resistance, that is 50, maximum 5, again the same value D max divided by twice the switching part, you will get the maximum value of inductance, that is raised to minus part, or we can say it is almost Henry. That in our it's 10. Once this we are separate of this inductor. Problem क्या है? You will get various types of capacitor, types of inductor have to create on our own. Different or another cores are available. Create inductor on our own based on the number of turns that you are going to calculate. So the separate discussion will be there. Just this numerical will over. We will start with the design of inductor. कि inductor को कैसे बनाते हैं? Because this is the customized value that you have calculated. It required as per our application, as per our load requirement, inductance value will change. Pass clear? Inductance then my now This is voltage we have output 8.03 volt. So value of now require, that is current MOSFET, so that IO divided cycle, another, there is a multiply this value of duty by 2 frequency calculation previous step micro are known to us, that is cycle हमें पता है, that is 0.778 output maximum value, so switching frequency, and this is a value of inductance 10 microhenry. So I have substituted all the values, and this is the value of stress, that is 35 point, because maximum voltage which is going to लगाया है, that's why I have diagram thoroughly illusion of and capacity, how appear should be calculated. The and in where two where yes VC max we require the and IDM, that is maximum value to be flow divided by 35, just 0.0851. Uh, the maximum value of capacitor formula, maximum value of duty cycle Dmax multiplied by output voltage divided by switching frequency multiplied by RL max and multiplied by VCP. Okay, so I substitute all the values by, that is 100, and this is RL max, that is 3. If you calculate substituting all the values, it's 10.3 microfarad. Okay, calculation of capacitor, and in the previous step we have calculated the value in 9.8 microhenry, and what it is microfarad. Step, because now we are ending part. Yes. Yes, hello, am I audible?
Yes.
Okay, okay. Any queries until the calculation of capacitor? Any point or any formula that I have to repeat? Please let me know.
So just one request, sir, can you please share this Word file actually so that students can see parallelly?
Okay, okay.
Thank
Just 1 minute.
Ashwini, come fast. Ashwini, come here. नेट का इशू हो गया है, तुरंत क्या करूँ मैं आपको? मैं यहाँ पे नेट मेल ऑन नहीं कर सकता, मेरा ये ओबीएस रिकॉर्डिंग चल रहा है. सर इज सेंडिंग इट एक्चुअली, आई टोल्ड यू टू सेंड द वर्ड फाइल ओनली सो यू कैन सी डायरेक्टली. क्योंकि आपका आधा ब्लड हो रहा है ना एकदम. मोबाइल निकालो, मोबाइल का शेयर किया. Okay, I think students are shared the drive link in that in this chat box. Please check.
Uh, uh, I have shared the uh, drive file of the DC to DC boost converter design. You can access that PDF file if you click on the link. So in the chat box, you will find the PDF file. Okay. Can I continue, sir?
Yes, sir. Please.
So students, you can parallel and parallelly design boost converter output voltage tested to calculate this numerical given at the uh, calculation of capacity frequency for this is 1 upon the capacitor that uh, 50. So 1 upon 10 to minus 6 multiply by the that is our frequency value, that is 50 hertz, not load resistance, that is frequency 50. So 1 upon 2 pi fc, so it will be 308.14 hertz. Okay, the corner frequency of in inductor current, all the values again x is equal to dmax. So max divide duty cycle, that is 1 minus 0.775. So the maximum value of inductor current is 17.78 ampere. Okay, and power loss that everyone knows. Next step is very easy, calculation of inductor power loss, that is I square R losses. Value of current flowing through the inductor is 17.78, uska square. It will be multiplied with the resist it is a specific value of resistance of the inductor 0.0. This is 8 point, and the last conduction loss square R losses. Calculate this values is IRM is going to be flow through our power, and the root multi maximum. Just substitute all the values. Maximum duty cycle multi हमारा minus duty points 50 that we have all why power loss during using. Here I have used conduction loss, that is I square R losses. This calculation is much similar, and here we have calculated the power loss I have used only current going through the inductor. Calculation हमने पहले substitute किया the conduction loss. हमने जो current, that current is used for calculation of power loss. So how much power will be lost? 7 point will be the loss during the conduction of. So this is in the calculation DC to DC boost converter. Any calculation? Now you have the PDF also. What you have to do when to DC boost, put voltage change is as per uh, आप ज़्यादा वैल्यू इंडक्टर का को जितनी ज़्यादा रहेगी उसका the higher
I think voice is breaking the
of
students.
kilohertz 100
Voice break हो रहा है ना students?
50
सर को बोलो जल्दी, सर को बोलो.
kilohertz
इंटरप्ट करो सर
की
को, बोलो वॉइस ब्रेक हो रहा है.
जितना कोर छोटा होगा. So but be very easy to design that and your that's why frequency that is 100 kilohertz. Is clear to all of you? So, the specific I will just to the design and calculated. Here in this example it is 50 volt. Output voltage according to your application, here it is 200 volt. Current which depends on the load or for this boost converter, that current here it is 4 ampere. Output power just a product of 100 watt. Resistance RL we have calculated. cycle also we have calculated, that is 0.775. In the percentage it is 77%. So I can say this is the limitation for the boost converter. Beyond this value of duty cycle, that boosting operation is becomes difficult, it's not possible. So we can increase the duty cycle up to 77%. After that it will become more reach into the saturation part. After very important values, inductance and capacitance. uh, Value of inductance we have just calculated, that is 9.8 microhenry, and value of capacitance, that is 10.3 microfarad. So is the all the values and the calculation, I hope it is clear to everyone. And now I will start with the last topic of morning session of this workshop, that is design of inductor. जैसे कि मैंने पहले बताया, this is a very practical problem. It is in the simulation you can use this value, but right now you have the power electronic design lab working on your major capstone project of sem 7, and at that point you require the hardware design. And whenever we want to design converter, the most important part of converter design is design of inductor, because आपको 10 माइक्रो हेनरी का इंडक्टर मार्केट में नहीं मिलेगा. Capacitor you can select any value that is close to 10 microfarad. But what customized value, so by hand से हमें वो वाउंड करने, हमें टेस्ट करना. पार्ट ऑफ माय टुडे फर्स्ट पार्ट वो ऑफ बूस्ट कर in the design of boost converter and turns, that is the design. Okay, okay, can I continue or any query? So if you see the starting I or toroidal core inductor circuits or the SMP, the inductors which are used. What is inductors based on? Okay, I will. This is okay. So inductor that we are going to idle core. This is a circular shape. Okay, every इसे क्या कहते हैं? Visible. This type of this. Yes, everyone. Right, it works on the principle of mutual regular transformer volt, can say, that we are using in used. These are the various applications. Right now, the design of inductor. Inductor calculated. We have just calculated the value. My following steps of product area is area of core is nothing but product of two values, that is core. Okay, so ACAW start then calculation capital lambda, then calculation of number of turns, कितने turns हमें वाउंड करने होंगे इंडक्टर पे, and what is the wire gauge, which conductor enameled by to wound those turns. वो turns वहाँ पे वाउंड करने के लिए कौन सा लेना चाहिए, that is a selection of gauge. Okay, so we will start, that is share. So you can start. I will share this PDF with you. Hmm. Yes, all the participants chat box. In the chat box, the drive file link of design steps of inductor I have shared, and you can open that file own. So, these are the different steps of what is the requirement, why rating, that is a very fundamental requirement. Core materials such as fair steel, okay, to affect your site. Okay, so second and important step is selection of core. How to use core table we will see in this how to choose or the conductor that we are going to use करने वाले हैं, how to select that gauge. Okay, so this is number of uh, you can use the most commonly winding file maintain number of जितने calculating calculation में आपके number of maintain that actual. Okay, insulation.
Sir, voice
Okay,
got interrupted in between. This last few sentences.
am I clearly audible?
Yes, sir.
I was discussing in previous minutes about what are the different steps are involved in from the inductance value that we just calculated in this microhenry for select we are going to wound on the insulation and okay inductor design अभी हमने DC to DC we will now start with the design of okay am I clearly audible so that I can start with
Students, बोलो sir को.
Yes, sir.
we will go the inductor value inductor design of DC to value 9 Henry. Okay, here is the most important inductor and for calculating we have the step. Okay, I is nothing of product AW and core but that is in the numerator part twice EL KW then current density that is Z value of M. Okay, all these are the constant values Kw, Kc, all or the flux density that we can select. But EL we have to calculate. EL is nothing but our the very popular formula, and that formula of L multiplied by the square of value of current. So this is the stored 0.8 of current into the square of 4 multiplied by 10 raised. Obviously, if you are calculating joules, all the value numerator while calculating the area are the design parameters that we do for single winding inductor. Here we are designing for single winding Kw is 0.3 current density. This is the current density for the 10 raised to 6 current density. If everyone is not clear about this parameter, current density is nothing but value of current flowing through per unit area. इसीलिए हमने करंट के वैल्यू को मीटर स्क्वायर के साथ उसका रेशो लिया है एम्पियर पर मीटर स्क्वायर. So that value for ferrite type of core is a constant 3 into 10 raised to 6 ampere per meter square. For the same type of core that BM की value to select again idea about the talking about magnetic flux. Magnetic flux is present per flux linkages per unit area, or you can use value for fair. This is the by IO. Okay, max 0.05 values product, and you will get a core area race. Okay, value one by one in the numerator, twice the 8.64 multiplied by divided by एक है फोर फैक्टर के करंट डेंसिटी सब finalize this area product relation. Can I, it's clear 5 points raised to 4. Per table will 4 and any like L Rashid had core tables, same source that I am using. Up to first AP के area की value of AP points which core using toroidal core, which part हम practice जो भी selecting related follow that calculate key value of the calculated value. Here this core table shapes course each toroidal core is different value millimeter. All this in our this is the core area and this is the area product. First we have calculated area product. तो हमने is a value which is greater than 365 stable mm raised to 4 value that PD the value greater than 360 greater value is 5. Which core I have selected? The toroidal core that I have selected is T12. Okay, and once I finalize this, I will use all these values: mean length per magnetic turn, LM, then core area, window area, M square, and calculation. Okay, single phase. Am I right? They have referred by using area T12 where W ये from the core. So 44.2, what is 30.4? Mean magnetic length Lm. Here in the third column it is 30.4 mm, and relative permeability, this is 200 mu r. The permeability and relative permeability mu naught, that is 4.2 10 raised to minus 7. And regarding the use of core table, I hope you are with me. Yes, because we are reaching towards the
Yes,
end
sir.
of inductor design. कोर टेबल यूज करने में कोई दिक्कत है तो बताओ. Yes, how calculated the value जाके उस क्लोजेस्ट ग्रेटर वैल्यू है टोराइडल कोर कोर the slightly greater all the parameters calculate calculation, that is permeance. This symbol is capital lambda. What is the formula? The formula is in the numerator I have, जैसे कि मैंने अभी बताया, absolute permeability not multiplied by mu r multi, that is from the core table. In the denominator I have Lm. Lm is nothing but mean magnetic length, Lm plus product of mu r into Lg. Okay, so Lg is nothing but the air gap length that we have to assume, and air gap length is 0.5 millimeter. Okay, I have highlighted this part. Okay, 0.5 millimeter. तो करना कुछ नहीं है, सारे वैल्यू फॉर्मूला में सब्स्टिट्यूट करने हैं. यू विल गेट द वैल्यू ऑफ परमी वैल्यू. नेक्स्ट स्टेप में हमें नंबर ऑफ टर्न्स कैलकुलेट करने हैं, एंड फॉर द नंबर ऑफ टर्न्स यू विल रिक्वायर दिस वैल्यू, बिकॉज परमियंस इज इक्वल टू इंडक्टेंस डिवाइडेड बाय नंबर ऑफ टर्न्स का स्क्वायर में डालने वाले हैं. नंबर ऑफ टर्न्स इज इक्वल टू स्क्वायर रूट ऑफ L डिवाइडेड बाय द परमियंस, और वहां पे हमें ये वैल्यू लगने वाली है परमियंस की. आर लिंक्ड विथ ईच, नॉट जस्ट वेस्ट ऑफ योर टाइम calculations, because each value is required in the. So if you substitute all permeance, that is capital lambda, the symbol is 4 pi into naught mu mu or this is plus or minus 25%. C core millimeters 10 raised to minus 6. In the denominator आएगी जो हमने यहाँ पे 30.4, so 30 कैलकुलेशन हम मिनट है तो into meters. Okay, minus 3 plus mu r again 1500 multiply by Lg. Lg मतलब क्या, मीटर 3. Yet 10 this is nothing square conversion. Millimeter 6. Okay. So if you do this or you will get that is 2.8984 multiplied by 10 raised to minus 8. Why I am calculating require calculation of number of turns आपको हाथ से वाउंड करने हैं कोर पे. That is the number of turns right now we are calculating. Very important value in the calculation of inductor. So, by permeance L ध्यान में calculate की divided by the permeance is 2 to minus both values. How many number of turns? अभी ऐसे टर्न्स तो मारने have to round next higher integer, that is 19. So what is the value of number of turns inductor for this inductor? It is 19. Yes, I hope you are with me. We started with area product. We selected that higher area product for toroidal core. T12 toroidal core we have selected. We have referred all the values. Using the values from the core table, we calculated the value of permeance. We the gauge. How to for that area हमें मार्केट से दुकान में जाएंगे तो वो पूछें कि कितना एरिया है आपके कंडक्टर का. Then only he will give you the right conductor that you want. So that area calculation is required. Then only you will finalize the gauge. Area and gauge, both values you are going to require in the market. And you want to buy for winding the inductor. Okay. Area is current divided by the density. ये density को हमने rearrange किया है. What is density? Current divided by area. By rearranging the terms, you will, if you know the value of current and the current density, you can calculate the area. And here area is 1.334 multiplied by 10 raised to minus 6. मतलब 4 जो हमने क्लोजेस्ट वैल्यू ली है दैट इज 4 mm². ये जो वैल्यू आई है 1.334 उससे तो ज़्यादा हमें सिलेक्ट करनी पड़ेगी. जैसे हमने एरिया प्रोडक्ट के टाइम किया था. व्हाट इज द एरिया प्रोडक्ट? 365.71. We have to select the higher value than that. In a similar manner, we have to use now the wire table. How much area that we are calculating? 1 millimeter square. The value यहाँ पे कौन सी है? Because it is better higher value. So we are selecting which gauge? SWG value is 13. Okay. 4 mm². Diameter will be 2.4. Resistance per kilometer is 4. I will use all the values for my winding. So for enabled copper wire that I am going to use for winding my inductor, having standard wire gauge, SWG stands for standard wire gauge, it's 13 and its area is 4.28 millimeter square according to the wire table. So this is the last step in the design of inductor. I will quickly summarize how we have started and how we have reached to the number of turns and the standard wire gauge. We have started with the calculation of inductor value. In the calculation of DC-DC boost converter, we have calculated this 9.8 microhenry. I'm using this value for calculation of energy stored. Once I get EL, I will use that value for calculation of area product, that is AP. Now core table will come into the picture. Value of AP is 365.71 millimeter raised to 4. I will use the toroidal core table. थंब रूल हमारा कौन सा है, उससे ज़्यादा वैल्यू सिलेक्ट करनी है. सो आई विल सिलेक्ट T12. These are the values from the core table for the T12 ferrite toroidal core. Value of LM, AC, area, LM, all the values for calculation of permeance. Why I'm calculating permeance? Because unless and until I know the permeance value, I cannot calculate the number of turns. Once I reach to the number of turns, we will select the this wire gauge. SWG standard wire gauge is 13. Okay, so for all the is boost converter, inductor value 8 microhenry, your area product it's 12 millimeter square, permeance is 2.8984 Henry per inductor. कितने टर्न्स टोटल 19 टर्न्स वी हैव टू काउंट. एंड कौन से गेज के कंडक्टर हमें मार्केट से लेने पड़ेंगे, दैट इज SWG वैल्यू इज 13 and its diameter or its value in the millimeter is 4.289 millimeter. SWG is 13. Okay, so this is all about the design of DC to DC boost converter. From almost how to design. Now I will summarize all the points, and I will give you the time for any queries if you have. Okay, so DC, so two and value go through the rigorous boost converter is value 9.8 10.3 microfarad. The selection of inductor, and we go through the various calculation of inductor, and our inductor is saddle core ferrite material. Its number is T12. How to use core table, how to use wire table, that we uh, try to understand in this pre-discussion. So this is how you reach to the final step of hardware design of DC-DC boost converter. So any queries in this first session of the workshop? Because in the second session, hardware implementation of boost converter and the voltage source inverter part, that is design and implementation of half bridge inverter, it will be continued by Dr. Jayant Manesar. Any queries in this session? Boost converter?
No, sir, no queries until now.
Okay, okay. So I will shift the mic to Dr. Jayant Manesar for further instructions.
Okay, good afternoon, everyone. Uh, may I know, sir, when is your lunch break? How much time is left?
Yeah, so the next section we can start at 2 p.m. if you wish. Sorry. So the next section can we start at 2 o'clock?
Okay, so right now you want to break for lunch.
No, oil, sir. For 15-20 minutes, sir, we can continue.
Okay then. Okay, so I want to. I think it is
एक मिनट Sigmund, sir.
hello.
Sir, आपने क्या चेंज किया आपने नेट में क्या करेक्शंस किया आपने नेट अभी आया क्या नेट आपने कुछ टिपिंग क्या क्या इधर आया अभी अच्छा ठीक है ठीक है hello sir, is my voice audible to you
Hello,
all?
sir. Sir, shall I continue for 15 to 20 minutes?
Yes sir, please.
Okay. So, whatever converter you have designed, so you can see the simulation of it first, because mostly we need to confirm the design, or you can say validate the design. Shared. So, I can show you that boost converter. This is multi-sim live. So, online we can simulate this. You may use other softwares also. So, here it is. Are different, I think. So what are
Micro
0.8
capacitor microfarad 10
10 micro distance frequency
77 point and give 75.
no for our case
7.5.
yeah, so I just entered the values which
Yeah,
were designed calculated. When we run this,
just one. And reduce decrease. So
it is slightly higher than 200 is showing.
maximum duty cycle लगाते हैं ना सर
Okay,
60 to 70 duty cycle.
so you can see here this is input voltage 50 volts, and see this duty cycle. So this is maximum possible. We have simulated. So accordingly, as per the output required, loop give pulses to this switch. Mostly frequency is right. So no other device no used. So now implementing this practically, we need obviously some DC supply. 50-volt DC supply you can generate it by using suppose batteries, or maybe convert is that could be a any DC source, and then
काय तुला काय प्रॉब्लेम दरवेळी
already designed this inductor, then you have selected this diode and this switch and everything. So while practically making, you can make this power circuit by soldering it together. And then very important is this control circuit. Now there are two ways in which you can generate the gate pulses to this. One is analog circuit, another is digital. Digital means using microcontrollers. So using analog, if you want to make this gate pulses, then you may go for stable multivibrator between IC5 and a stable multivibrator. The circuit you have studied, slight modification is required to get variable duty cycles. Okay, so down here. So this is the multivibrator circuit. Okay, so
So the
you
voice
have,
got broken between actually. Can you please repeat the last two sentences?
yes sir.
So voice got broken between. It got interrupted. The last
You
two
did.
sentences. Can you repeat? Yes.
I told that this is a power circuit. Power circuit design you have already studied now. Sir has told you power circuit. Now control circuit design is different one. Now this required frequency cycle need to be using digital or analog circuit. So analog circuit means you have to use a stable multivibrator using IC 555, and whatever you have studied in the syllabus or subject, maybe ADIC or something like that, analog electronics. In that you have studied multivibrator, but constant duty cycle, fixed duty cycle. Here we want variable duty cycle in DC to DC. We can go, we can build any potentiometer. So here we use this potentiometer to analyze the DC signal. Okay, and required. And these pinouts you can see, these are different pins of IC 555. It is 8-pin IC. These reset pin, VCC pin, diode. So they it, and from this value, this resistance, this pot form here. Firing this pot, you can. So when I simulate this, see this square waveform. Okay, we get a and if we change the pot potentiometer value, okay, instead of 50%, we can go for 90% like that, and once again run it. Okay, so you should see the difference in the on time and off time. That is what the duty cycle is. Okay, so this is one way, very simple implementation. Then you have to develop one power source. Okay, for this now DC given to this circuit, output of this obviously cannot be more than 5 volts. So this circuit will give you or generate a 5-volt magnitude square wave. But to drive any MOSFET or IGBT, we need 15-volt magnitude signal. Uh, depending upon MOSFET or signal has to be old signal. Again, there is required power switch in on. My current is also using. So these are they can signals which, but they cannot duplicate. You need, so that is what. So you can say, and have to connect driver design. Will see providing these pulses is controller using multi sim live here at website from Autodesk. Microcontroller, and there is a potentiometer connected to pin number 9, pin number A0. A0 is analog input pin. So this potential 0 to 5 volts at A0 pin. And then I have written a program. Okay. PWM at pin number 9 with cycle 0. You can see here and voltage value. So 0 to 255. These values are used as duty cycle. So what is 0? 0 is duty, 0 duty cycle, and 255 means 1. So 5 volt into 1023 number of values, 80 resolution. So these many values mapping. Okay, and 255 means 1 written, and see the instead of PWM pulses are getting generated, and if I change the pot value, the blinking. So this is another way. So through this potential, accordingly at pin number 9, the PWM is generated. Now again, this is digital circuit, a simple, and this can generate any desired signal, but obviously it cannot drive the further circuit, or it cannot drive the MOSFET switch. Have connect gate driver. So circuit, or you use in any gate driver IC. So yeah, what I have done is I have this is in I am using Eagle software for make you can say software in which you are using IC PC9 to 8 pin IC. You can see here. Okay, there is a connector, VG connector, which is at which is of MOSFET, and there is also this source terminal. Okay, drain, source, and gate are the three terminals of MOSFET. So this is the MOSFET. This is inductor L1. This is input voltage, and like that. So to drive this MOSFET, I have to give pulses, and you can see this circuit now, and see this terminal VG. VG is name given here as well as VG name given here. That means on practical PCB, these two terminals will be connected by the software itself. Okay. Then there is resistance. Gate driver and resistor. Without it, gates. Otherwise, the gate circuit will get overheated. There could be extra power loss at gate driver. So typically, or by thumb rule, you can take 10 ohm or up to 22 ohms of the value for this gate resistance. Now, to get resistance value accurately, you have to refer data sheet of MOSFET and its input characteristic. And there, in the input characteristic, you can see how much is required to completely turn on the MOSFET. So to that value, you have to select refer datasheet of MOSFET and design. By thumb rule, you can take 10 ohms between anything electrolyte ultra fast this. Okay, simple IC. You can see ground pin, then there is VCC pin, 12 volts. You have to then and there is a capacitor. So here it is a low side driver. This is low side driver. What is a low side driver? Means whatever potential of this main circuit. This is the reference potential, negative terminal, negative wire, which is running from this input up to output. This is the reference potential or ground, we can say. See ground here. So with if the source of the MOSFET is connected to this reference, we can say it is low side switch. Its source reference potential. So we can use a low side driver. So this is the low side driver. Now with respect to this source, you have to apply 15 volt PWM pulse at the gate. So this source must be connected to this ground. Okay. This ground and this ground must be same. Then you can see this PWM input. So whatever is digital or analog circuit that has to be given to this driver will and it will take this input to this IC is driving the MOSFET in on current.
Sir, can you please repeat the name of the driver IC?
This is driver IC.
So we could not hear, sir.
C923. This is
3923. Okay.
you can see this converter connectors are for maybe input from this all you can see gate pulses is the voltage the driver capacitor all these resistance. Okay, then this is the MOSFET switch, this is the diode output capacitor. Okay, this is the circuit which is made. So I'll show you the data sheet of this PC923. Seed opto IGBT driver. Now what is optocoupler? Isolate output. So see the internal diagram of this IC diode between two gate or here at pin number grounded. The ground or IC 555 ground should be also connected here. So output pulses are given here. So this LED will be blinking. This is LED. LED will be blinking inside the IC. Then there is, you can say here, photo transistors. So there is some other circuit also, and there is actually amplification is there, and there is photo transistor actually. So this light falls on the phototransistor's base, and then it generates current in that phototransistor. This 5 volt given between 2 and 3 will get amplified. Okay, here. So you can see this terminal 6, okay, can be used as a that way you can connect the gate, all gate drivers. You will get online. Don't find PC923 gate driver. There is another very which T2LP. So that all opto drive stage. You can say combination IC. We use IC separately. So due to isolation circuit, you can say harm to. Okay, there are so many, and input current and output is also given. Refer the data given, waveforms are given. What is the rise time, fall time, means how far time this can drive the MOSFET. Okay, that should be matching. It should be matching with the MOSFET. So you have to see the highest operating frequency of this. Okay, and you can also see this application note, application circuit, or there could be separate application note published by the manufacturers. So this is 3-phase inverter shown here, and here high side driver is shown. This is a high side driving. So you can see here, this source of this MOSFET is not always connected to negative terminal. Okay, this is floating. This is floating around. Therefore, this is high side driving. So some you can say application notes are shown here. Okay, so after the components, see this gate driver PC923. There is this capacitor 10 microfarad, this ultra fast diode UF4007, and this resistor is of 22 ohms. Okay, red, black, 22 ohms. This is the MOSFET, and I have also heat sink to this MOSFET. You can see the screw also, heat sink. This is the diode. To that diode also heat sink is connected. Okay, this is the inductor, EMI filter, capacitor, and all of that. So see these waveforms. Okay, these are actually closed loop, and we have made closed loop and all of that. So, but in hardware, okay, we can get these waveforms like this. Taking this PCB, generally you keep as possible to this MOSFET. 100 kilohertz or gate driver wire between MOSFET. As okay, sir. Is there any doubt now?
Okay. Okay, sir. So shall we take a break of half an hour then? At
Yeah,
2 o'clock, at 2:15 we'll come back.
yeah, yeah.
So
Two,
all
two,
the
2 o'clock
students
we'll
take a
start.
break of half an hour. At 2:05 you should be back to the meet. Meanwhile, all the students please come and sign in the attendance sheet in my lab. Okay, thank you, sir, for the first half.
Thank you.
Okay, students please come and sign in the attendance sheet.